So, good morning, friends. So, welcome to the series of percentage. So, in last video, I discussed about how to find the percentage and what are the various fractional values in terms of percentage. Like 1 by 2 is equivalent to 50%, 1 by 3 is equivalent to 33.33%. So, like that, at the end of that video, I talk about the concept of 2 and by. So the concept of 2 and y is little confusing for the students. So I have taken two examples and where I will tell you about what is the meaning of when we say that this particular thing is increased by this percent or decreased by this percent. And on the other hand, if we say that this particular value is decreased to 10% or decreased by 10%, then so I will tell you about these two terms or can say two words meaning here to and by. So the first example is population of a city is increased by 20% in 1 year. If population at the beginning of year is 10 lakh, then the population at the end of the year will be. So for this particular, we can say if what is the nature of increasing of percentage? I don't care. Suppose the population is increasing like this. So at the beginning of the year, it is something around 10 lakh. And if it is increasing, and if it is increasing to, can say 20%, okay, increased by 20%, okay, increased by 20%. So initially, if it is 10 lakh, then if it will be increased by 10% or by 20%, then what will the meaning? So when we say that it is increased by 10%, then this by 20% or 10% is applied on this initial value. So suppose this initial value is 10 lakh and his population is increased by 20%. So then 20% by means multiplied with this 10 lakh. So if a population is increased by 20% in 1 year, suppose this is the time axis and this is your population axis. Initially it is 10 lakh and after 1 year, suppose this is the 1 year, end of the 1 year, and in between there is a different times, can say 1, 2, 3, 4, 5 months. So your population is increases, suppose something like this, whatever the characteristic of increasing the population. But at the end of the year, the population will increase by 20%. So whatever the population is today, add 20% of that population in the same population. Means if it is increased by 20%, so 20% of 10 lakh will be 20 by 100 into 10. So it will be 5, it will be 2 lakh. So if population is increased by 20% means initially population was 10 lakh plus it is increased by 20% means more 2 lakhs. So it will be 12 lakhs. It will be 12 lakhs at the end of the year. So here the population will be 12 lakh. If on the other hand we say that, if on the other hand we have the example, suppose the population of city will be 50 lakh in 10 years. So we have given a time like this. Population will be 50 lakh and whatever the way of increasing, I don't care about it. But if the currently the population is 10 lakh, then time taken for reaching the population to 25% of total. To 25% of total. It means if the total population is 50 lakh, then 25% of that population will be. So 25% of total population, 50. So 25% of total population, 50, it will be 2 and 12.5 lakhs. Okay, so it will be 12.5 lakhs. So here it is 12.5 lakhs. Initially it is 10. So here it will be 12.5 lakhs. And whatever the time this T naught indicate that your population has been increased to 25% of total. So this is the meaning how to deal with the 2 And I have taken this separate example where I have shown that some quantity X, which is decreasing with respect to time. So it is a most generalized example, which we usually use for many engineering variations of quantities. Suppose if you know the discharging of various elements like capacitor, inductor, in terms of, if I talk about engineering language. So generally we can say this is some quantity X which is decreasing with respect to time. So initially this quantity when time is zero, can say when it is started, its value is 50. And after some time, or can say after some large time, we can say, suppose it is your 100 tau. After a large time, after you can say 100 tau, it is in decreased to zero. So if we say, then if we say the time taken by this characteristic, time taken by this characteristic, the time taken for decreasing, time taken for decreasing it by 10%. First case. In second case is time taken by it, time taken by it for decreasing to 10%. So there are two different cases. In first case, we are talking about the time taken for decreasing it by 10%. Or second is time taken by it for decreasing to 10%. So here is, it is decreasing to 10% and it is decreasing by 10%. So initially it is 50. If you talk about the decreasing by 10%, so 10% of 50 will be decreasing by 10%. Okay. So 10% of 50 will be 5. So decreasing by 5 means it is 45. So it is 45. And this is the time for first case. Suppose it is T1. Okay. So it is T1. In this, we have shown this particular quantity is decreased by 10%. Means it is now for 90% of total. Because it is decreased by 10% means it is 90% of total, which is 45. And the second case, time taken by it for decreasing to 10%. Of decreasing to 10% means 10% of 50, and 5. So 5 will be something here. So this is 5. And this is your T2. This is your T2. Okay. So T2 is the time when this quantity is decreased to 5, and T1 is the time when this quantity is decreased to 45. So this is the difference. But in both, we have 10% criteria, but one, in case 1, it is by 10%, and in the case 2, it is 2 to 10%. So we have to understand this difference. We will use these things in questions. So this is enough for this video. So thank you.